In this example, we have 15 and then a big open bracket, and we have 3 terms inside of that bracket. So I'm going to try to deal with each of these terms nice and slowly. There's multiple layers of fractions, so let's try to unwind this step by step, nice and slowly. So we have 15 and then big open bracket, big close bracket, and we'll deal with each of these terms one by one. So maybe this first term, let's take the 5 over 7 and group that together. So there's the big dividing, 2 divided by everything below. Let's deal with that first. Let's take that division sign and change it into multiplication. So it's 2 multiplied by the reciprocal of what we have. So 5 over 7 was on the bottom. 5 over 7 comes to the top. And 3 was on the top, and it goes to the bottom. So that's our first term sorted out. Okay, let's take a look at our second term now. So I have 2 over 3 divided by 5 over 7. So I'll exchange this division right here for multiplication. So I have 2 over 3 is now multiplied by, instead of 5 over 7, 7 over 5. And the final term that's inside of my brackets, I have 2 divided by 3/5, so I'll group those together, and then it's all being divided by 7. How about we first deal with the divide by 7 one as well? So we'll deal with the biggest division first. It's like all of this top part here divided by 7. So what we would have is 2 divided by 3/5 multiplied by, instead of 7, 1/7. Okay, so in our next step, let's try to get rid of the multiple layers of fractions, so we just get it down to like one numerator and one denominator. So we have 2 multiplied by, and then in the brackets we have 5 over 7 here. So how about, instead of writing 5 over 7, we exchange that divide by, 5 divide by 7, to 5 multiplied by 1 over 7. So we would get 5 multiplied by 1 over 7. We can just put the 7 right on the bottom. And there's a 3 on the bottom already. In the middle term, things are kind of nicely sorted out already. We have 2 times 7 over 3 times 5. And in the last term, we have 2 divided by 3 over 5. So let's take that, 2 divided by 3 over 5, and use our rule to exchange that for 2 times 5 over 3. And all of this is multiplied by 1/7. So we can write multiplied by 7 in the denominator. Now when we take a look back at what we have here, the first term is exactly the same as the last term. So all of this can cancel out with all of that. Behind the scenes of that canceling is we have additive inverses producing 0, and 0 is our identity, and the identity kindly will disappear for us. So we just are left with 15 multiplied by negative 14 for the 2 times 7, all divided by 15 from the 3 times 5. Again, now we have multiplicative inverses, 15 multiplied by 1 over 15. So those cancel out, produce 1, 1 disappears, and all we're left with is our answer of negative 14.